Today, we're diving into something truly beautiful, complex, and, well, mostly invisible. We're talking about fluid dynamics, and we're going to uncover the hidden patterns in pretty much everything that moves. Have you ever just watched a single drop of ink hit a glass of water, and see it bloom into these incredible, complex shapes? Or how about the smoke from a candle? It just twists and swirls, creating these little patterns that are never, ever the same twice.
Or maybe you've looked up and seen a massive jet just slicing so cleanly, so powerfully right through the sky.
Well, believe it or not, all of those things, the ink, the smoke, the jet, are all connected. They're all expressions of the same hidden science, fluid dynamics. And it just happens to be one of the most beautiful and most challenging areas in all of physics. It's kind of running the show in ways we rarely ever stop to notice.
So, to really get this, we have to start at the heart of it all, with the nature of flow. And that starts with a super simple question. What is a fluid anyway?
In physics, the definition is actually wonderfully simple. A fluid is basically any substance that can flow. It doesn't have a fixed shape, and it gives in really easily to any outside pressure. Simple as that. If it flows, it's a fluid. And this idea is way broader than you might think. I mean, sure, liquids like water are obviously fluids, but so are gases, like the air that's all around us right now. And if you go cosmic, even plasma, the superheated stuff that makes up stars, that's a fluid too. It's this amazing flexibility that lets fluids create everything from a gentle stream to a monster hurricane. Okay, so now we know what a fluid is. Let's look at how it moves. Because when fluids get going, they basically have two completely different personalities. You can think of it as the two faces of fluid movement. Calm versus chaotic motion. So on one hand, you've got what's called laminar flow. It's smooth, it's layered, it's almost elegant. Think of honey slowly pouring from a jar. But then, you push it just a little bit faster, or you change the shape it's flowing around, and all that beautiful order just collapses into its total opposite, turbulence. And this is pure chaos. It's a wild, unpredictable swirls, little eddies, motion that literally never repeats itself. And this is just, it's so wild. Turbulence is so incredibly complex that even today, with all our computing power, we still don't have a perfect set of equations to describe it. It's no wonder people say it's one of the last great mysteries of classical physics. Which, of course, brings us to the next big question, right? What is it? What's the switch that decides if a fluid's flow is going to be nice and orderly or just completely chaotic? Well, it turns out there is a kind of hidden rule book. And amazingly, there's a single number that basically makes the call. It's called the Reynolds number. And this is an incredibly powerful idea. A single value, that's it, that you calculate from a few key things, and it can predict whether fluid's flow is going to be smooth or totally chaotic. So, what goes into this magic number? Well, it's a mix of four key things: how fast the fluid is going, its density, its viscosity, you can just think of that as its thickness, and the size of whatever it's flowing around. When that Reynolds number is low, flow is smooth, predictable, but once it gets high enough, chaos takes over. This one value is the secret sauce behind everything from a gently flowing river to the design of a supersonic jet. All right, so fluids can be calm or chaotic. That's cool. But they can also do things that look like they're defying gravity. Let's dig into the secret of lift. And the secret here is something called Bernoulli's principle. And it's one of those beautifully simple rules with huge consequences. All it says is this: as the speed of a fluid goes up, the pressure it puts out goes down. Faster fluid, lower pressure. That's the whole game. So how does that simple idea get a 400-ton airplane off the ground? It's all about the shape of the wing. See, the curved top forces the air to travel faster over it than the air traveling under the flat bottom. And what did we just learn? Faster air on top means lower pressure. Slower air on the bottom means higher pressure. And that pressure difference creates a massive upward force. And just like that, you have lift. But hey, let's jump back to that idea of chaos for a second. Because even inside what looks like a totally random mess of turbulence, we can find these incredible repeating structures. This is where we get into the magic of vortices. Vortices are these amazing rotating structures that prove that even chaos has some kind of underlying order. You've seen them everywhere: a whirlpool in a river, a perfectly formed smoke ring, a terrifyingly powerful tornado, and if you want to go really big, Jupiter's Great Red Spot, a storm bigger than our entire planet, is just one giant, incredibly stable vortex. So let's bring all this back down to Earth, because once you get these basic ideas, you start seeing fluid dynamics absolutely everywhere. You start to see the entire world in motion. Seriously, the reality is you're interacting with fluid dynamics all the time, from the second you wake up to the second you go to sleep. Just think about it. The steam rising in those turbulent little swirls from your morning coffee. The wind resistance you feel pushing against you when you run. That pocket of calm air, the draft, right behind a cyclist. The sleek, aerodynamic shape of our cars, all designed for smooth flow. The little vortex water makes as it spirals down the drain. Even the perfect spiral of a football pass. It's all fluid dynamics, right there in front of us. And you know what the most amazing part is? All of these things, from the tiniest swirl of cream in your coffee to the biggest hurricane on the planet, are all governed by the exact same set of physical laws. Every single curve, every motion, every swirl. It's all part of one universal pattern. You know, at the end of the day, it really makes you see the world differently. It's like the world is this giant canvas of flowing matter. And every single drop of rain, every gust of wind, every ocean wave, it's all just another part of the same magnificent cosmic dance.